I am on page 188, and we are looking at two examples. In example A, it says for the function f of x equals x plus 1, graph the point whose x coordinate is 2. So we need to find a point. We need to find the other half of this coordinate pair. So I'm going to let x be 2. And that means that y is 3. So the point we want to graph is 2, 3, over 2, up 3. And then example B, we want to graph the point whose x coordinate is positive 3. So let's just plug in a positive 3 for the x's. And so x is 3, y is 1, and that would be right here. And that's all we have to do. Just plot the points where we're supposed to. In the margin, over there at the core skill, this is solving a real-world problem. Let me read it for you, and then we'll do what we need to. The function h of t equals negative 16t squared plus 256 is used in physics to describe the height h in feet of an object t seconds after it has been dropped from a height of 256 feet. So let me take just a second before we get to the question, and let's set up a table. And I think I've put it in the wrong spot, but that's okay. I can move it. Let's put him right there. So h of t, it tells us that the height is in feet of an object, and t is in seconds. So time in seconds, height in feet. Seconds is the independent variable. Height is the dependent variable, because the altitude, the height of the object depends on the seconds that have passed. We can also say that seconds is t, height is h in terms of t. So we could label it that way. We could also call it, let's just leave it there. Let's not call it anything else. Okay, here it comes. Evaluate this function when t is 0, when t is 1, my goodness, t is 2, 3, and 4. So we need to add some stuff to our table. This is going to be fun at midnight. Okay, so let me go ahead and put some rows so that won't look so peculiar. So when t is 0, 1, 2, 3, and 4. Okay, so we need to plug in each of these values into this function, and rather than have to write it, I'm not going to, well, yeah, I am, because I have to do it 5 times. We're just going to copy it so I don't have to keep writing it. All right, so the first one that I'm going to plug in is h of 0. So negative 16, 0 to the second power, plus 256. So when t is 0, h is going to be we know this is true because when no time has elapsed, the object is at 256 feet. Okay. Plug the formula in again, and let's use h of 1. So everywhere there's a t, I'm going to put a 1. So we have 1 to the second power is 1. So we have negative 16 plus 256. And that is going to be a 0, a 4, and a 2. So 240. After 1 second, the object is at 240 feet. Let's plug in again. And this time I'm going to use t of 2. So h of 2, or h at 2, is negative 16, 2 to the second power, plus 256. So this is going to be 4 times negative 16, and that is negative 64 plus 256 is 2. I'm not this late at night. You guys know that I cannot add and subtract in my head if it's not lined up. So 192. Again, let's evaluate when t is 3 seconds. So h of 3 is negative 16, 3 squared, plus 256. 3 squared is 9. So negative 16 times 9 is negative 144, plus 256 is 112. And after 4 seconds, let's see what happens. So h of 4 is negative 16 times 4 squared plus 256. I was wondering if this was going to happen. 16 times negative 16 plus 256. 16 times negative 16 is negative 256 plus 256. So the height with that point would be 0 feet. So by working that formula that many times, I was able to complete this chart. Now, we have to graph this thing. It says to graph the corresponding points in the coordinate plane and connect them to form the graph of the function. So let's do a coordinate plane. And do I need, hang on one second. I'm going to see if I can see a picture of it before I graph it. And of course not. Okay, so let's graph. I was hoping I could figure out the scale without having to actually figure it out, because this video is getting very long. But it's okay. Remember, the independent variable is seconds. Time in seconds. And then the height is the dependent variable. It depends on how many seconds have elapsed as to how many feet the object is. Now remember, the object was dropped from what altitude? 256 feet. So maybe someone was standing on the edge of a cliff and dropped this object. So the 256 is going to be up here. Okay. Now let me see. We got to get from 256 down to 0. So let me count my lines, and I'll show you how I'm doing this in case you ever have to. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'm going to do 256 divided by 18. And that means that each of my tick marks needs to be about 14 feet. So this is not going to be the easiest one in the world to graph, but we can do it. So here's 14. There's 28. 28 plus 14 is 42. 42 plus 14 is 56. 56 plus 14 is 70. 70 plus 14 is 84. 84 plus 14 is 98. I am using my calculator because I don't want to make a stupid mistake in below this. Just be sure that you have the right values. Plus 14 is 140. Plus 14 is 154. Let me just do this. Plus 14 is 168. Plus 14 is 182. Plus 14 is 196. Plus 14 is 210. This is not going to come out exactly right because it wasn't an even 14. But we'll deal with it. 238 plus 14 is 252. So let's go ahead and make that scale correct. And then another 14 would be 266, which is too big, but that's okay. All right, and then the time in seconds, we just have to do by fours. And I am going to spread this out. So 1, 2, 3, 4. That way I get a little bit of space in my graph. So when time was 0, the height was about 256. So I'm just going to guesstimate. It's okay. When the height was 1, when the seconds were 1, the height was 240. So about right there. When the height was 192, 2 seconds had elapsed. So let's go ahead and graph here. After 3 seconds had elapsed, the height was 112. And after 4 seconds had elapsed, the height was 0. And I did that and then I didn't pay attention. So 2 was what? 240. Because remember, I stretched those out a little bit. 3 was 112. No, 2 was 192. 3 was 112. And 4 was 0. So here's the graph. Let's see if I can do it with this. I don't know if this will work. This is going to snap. No, it didn't, but that's the shape I'm after. Let me just freehand it. It's not going to be pretty, but it'll work. Okay. So this graph, the slope is negative. It's falling. And it is representing the altitude at each second. And that is a tough problem. It's just a lot of work. But we have finished page 188.